cache. So design a data structure that follows the constraint of a least recently used LRU cache. So this is how we're going to implement it. So we have an LRU cache. We have to and we have a parameter called the capacity. So each LRU cache has we have to initialize LRU cache with a positive size of a capacity. Then we have a get method which returns the value of the key if the key exists. Otherwise it returns -1. Now we also have a put method which updates the value of the key if it exists. Otherwise, add the key value pair to the cache. Then it gives us a condition here. If the number of keys exceed the capacity from this operation, evict the least recently used key. The functions get and put must each run in O of 1 average time complexity. Now, looking at this problem, one thing I can identify is since we're using key value pairs, we also need to think of it with a hash map, right? Especially because we know that the retrieval, which is the get and the put, must each run in O of 1 time complexity. Now, looking at this question, there are some questions that I currently do have. In an event where we do not have the value there, what should we return? Right, okay. On this second row, it says that we should return -1. So we know that that's already one condition that we're going to use. So before we go into solving this question, let's first answer the question, what is an LRU cache? Now, an LRU cache is a caching algorithm that prioritizes the removal of data which has not been recently accessed or utilized. So let's say that we are trying to store different values inside our array, for instance, and we don't want values which we are not using frequently to be there, especially if we have a storage limit, if we have a capacity. What we're going to be doing is we are going to be removing the sets of data, the key value pairs which have not been used recently or which have not been mostly used in our algorithm. So in this problem, we are going to be having different operations. Like I mentioned, we have a put method and a get method. And so the put method says that we're going to be storing key value pairs. Okay, we're going to be storing key value pairs. When I think of key value pairs, I'm thinking of a hash map, right? Where we can easily store the values and retrieve them. But now we want to be removing the key value pairs based on their least frequently used item. And what we can be doing is we could use a queue to actually do this. But a queue, in this case, if we are storing the items and removing them, it would be on n time complexity, right? Because we'll be removing the elements from arbitrary positions in the list. Now, I want to do this in O of 1 because that was one of the requirements for the questions. So how are we going to do this? We can use the approach of a doubly linked list. Now, if you want to store the data in an orderly manner, such that elements can be removed from any position in constant time, right, in O of 1 time, we can use a linked list for this. And let's say that we have a linked list, right? Let's say that we have a linked list of A, B, C, D, E, right? Let's say that I want to remove C from the linked list, right? One way that I can do this is just by saying I'm going to say B dot next is equal to D. So this is how it's going to be. It's going to be A, B, D, E. And so you see that this already makes it easier for us in this case. Now, if I want to remove a node from the list, we need to have a pointer to the node before it. And because of this, we need to have a doubly linked list. So it's pointing to the node before and it's pointing to the node after. That way, if I want to remove the node, we can have a previous pointer to the node before it, right? So in this case, this was our prev, um, and then this is our new, we removed C. So first of all, we want to initialize a class for our list node in Python. I like using Python for data. I think it's easier, right? Because they have a lot of built-in functionality into it. So I'll be using a doubly linked list and a hash map for this solution. Why? Because I want to easily, I don't want to use the word easily. I want to be able to retrieve key value pairs and remove the list key value pair from the list used key value pair from from the list. Now, because I'm using a hash map, I'm going to be attaching a key to a node. So that's going to be the key value pairs. Now, the first thing I did was to initialize my list node class. So I created a list node class with a key, a value, and a prev and next. The reason why I'm using a doubly linked list is because if I want to remove an item from if I want to remove from the linked list, I need to have the previous value and the next value. That's why I'm using a doubly linked list. Now, also had to initialize attributes for my LRU cache object. So I have capacity, I have a dictionary, which, like I said, is going to be assigning keys, and then the values will be the nodes. I have my head and my tail because I'm going to be working with a doubly linked list. Then we also have the head value, which is going to be the tail, and we have the previous value, which is going to be the head. So it's basically pointing, and I'm going to show you how that looks. So I created two methods to help me solve this. So I created an add method and a remove method. Now, when I initially spoke about solving this problem, I mentioned how we're going to be using a queue. So the first item in is going to be the first item out. Why? Because let's say that we're in a queue, right? The first item in, and let's say that other items are coming after it. The first item is going to be the least used item. So we're going to be removing that first, and we're going to be adding items after that. So in this add method, what it does is that the previous end is set to the previous tail, which is actually the tail. And then our previous end next. So the next item after the previous end is going to be the node. Now, the previous item before the node that we just added is going to be our previous end. Then the next item after that is going to be our tail. So at the end of the day, the tail previous is going to be node. And I showed you this in a visualization. If we want to remove a node from our linked list, we're going to be saying node.prev.next, right? Which is the next item after our previous item is going to be the item after that one. And I'm going to show you that too in the visualization. Then the next item, which is the previous item, is going to be the node.prev. So I'm going to also show you that in a drawing, because I believe with linked list it's very important to visualize it before actually solving, because talking about it may be quite confusing. So in the question, we're meant to have two functions. I'm meant to have a get, I'm meant to have a put function. So the get function basically gets the value from the key if it's within our linked list. And then if it's not, we're going to be returning -1. So the first thing I did was I started with the base case, right? If key is not inside our dictionary, we're just going to return -1. Then if that's not the case, we're going to say that our node is equal to the value of the key. And we're going to be removing it too. So first of all, we're going to remove node, then we're going to add node to the front, meaning that, okay, this is being used. That's why I'm moving it to the front. Like I said before, a queue, and we're going to return that node value. Now, in our put function, we're taking in the value and we're taking in the key. And so if we do not have the key inside our dictionary, what we're going to do is that we're going to add it to it. So our old node is going to be the value of of the key. Then we're going to remove that old node. Now, the new node, we're going to initialize it as a key value pair, and we are going to store the value of the key as the node, and we're going to add it. Now, this is where it gets tricky. If the length of the dictionary exceeds the capacity which is given to us, we're going to have to delete it. So the node that we're going to delete is going to be the first key value pair, right? The first node inside our doubly linked list. We're going to delete that. Then this is how we're going to solve the problem. Thank you. So now let's talk about space and time complexity. The time complexity is going to be O of 1 because we're retrieving from a hash map, right? Not only that, we're going to be adding to a linked list or we're going to be removing from a linked list. So this is all going to be of constant time, which is O of 1. Then the space complexity, note that when we're adding or removing, all this is dependent on capacity, right? We would not exceed capacity no matter what. So the space complexity is going to be O of capacity. Now, thank you so much for watching. This is also a learning opportunity for me because I'm working on mastering data structures. So join me in this learning journey. Tell your friends about me. Like, subscribe, share. Thank you very much. Have a beautiful rest of your day.